This is a video from section 3.10. The directions say to use a linear approximation to estimate the given number. We're going to start off with 1.999 to the fourth power. That's a very inconvenient number to calculate by hand. And so, hence, we have this linear approximation technique. So we're going to let f of x equal x to the fourth. Now, 2 is a number near or close to 1.999, and we know 2 to the fourth is 16, and so what that tells me is a equals 2. Okay? Now, the formula, L of x is equal to f of a plus f prime of a times x minus a. But remember that a is 2, so I'm going to replace a with 2. So L of x is equal to f of 2 plus f prime of 2 times x minus 2. Now, f of x is equal to x to the fourth, so f of 2 is 2 to the fourth, which is 16. F prime of x, by the power rule, is 4x to the third, and f prime of 2 is 4 times 2 to the third, which is equal to 32. And so L of x is equal to 16 plus 32 times x minus 2. Now, we're trying to find an approximation for 1.999 to the fourth. And so what that tells me is I'm going to replace x with 1.999. And so L of 1.999 is 16 plus 32 times the quantity, 1.999 minus 2. But 1.999 minus 2 is negative 0.001. And so this is equal to 16 plus 32 times negative 0.001. And I claim that will give us an approximation to 1.999 to the fourth. And this bottom line is much easier to calculate than 1.999 to the fourth. So that's the whole point of this. Now, when we do the calculation, we end up with 16 minus 0.032, which is equal to 15.968. And so I claim that 1.999 to the fourth is approximately 15.968. Now, I'm putting this in the calculator to, I guess you would say, drive home the point. And from the calculator, we get that 1.999 to the fourth is approximately 15.96802, etc. And so you can see that this technique gave us a pretty good approximation, and it was accurate to 3 decimal places. And that was problem 31. If we take a look at 33, we want to approximate cube root of 1001. And so the function we're dealing with, we're going to let f of x equal cube root of x, which is equal to x to the 1/3. Now, I happen to know that the cube root of 1000 is equal to 10. And so that tells me a equals 1000. L of x is equal to f of a plus f prime of a times x minus a. And so L of x is f of 1000 plus f prime of 1000 times x minus 1000. So I just replaced a with 1000. F of x is equal to cube root of x. When I take its derivative, I get f prime of x is 1/3 x to the negative 2/3. That's just power rule. And I rewrote that as 1 over 3x to the 2/3. Okay? Now, f of 1000 is equal to 10. So, again, I just took cube root of 1000, and you do get 10. F prime of 1000, you can see, is 1 over 300. And so L of x is 10 plus 1 over 300 times x minus 1000. And so, if you remember, I'm trying to find cube root of 1001, and so I need to replace x with 1001. It's the same procedure as problem 31. And so L of 1001 is 10 plus 1 over 300 times 1001 minus 1000, which is 10 plus 1 over 300. And this is approximately equal to 10.003. And so therefore, cube root of 1001 is approximately 10.003. And, you know, we could still put this in the calculator. Just, again, we can drive home the point. If I take the cube root of 1001 from the calculator, I would just like to tell you what I end up with. Oh, calculator, right? The cube root of 1001 is approximately 10.00333, etc. And so you can see that we get a pretty good approximation for the cube root of 1001 utilizing this technique, okay? And that's 33. If we take a look at 35, we want to approximate e to the 0.1. And so we let f of x equal e to the x, and we happen to know that e to the 0 is 1. Again, 0 is a number that's close to 0.1. That's key. And so I'm going to let a equal 0, okay? L of x is f of a plus f prime of a times x minus a, and replacing a with 0. And so L of x is f of 0 plus f prime of 0 times x minus 0. F of x is equal to e to the x, and so f of 0 is 1. F prime of x is e to the x, and f prime of 0 is 1. If we put everything together, we get L of x is equal to 1 plus 1 times x minus 0. And I need to replace x with 0.1, and so L of 0.1 is 1 plus 1 times 1, L of 0.1 is 1 plus 1 times 0.1, which is equal to 1.1. And so e raised to the 0.1 is approximately 1.1. And again, we can do this from the calculator again and drive home this point. So from the calculator, e to the 0.1 is approximately 1.105170918, etc. And so this technique gave a pretty good approximation to e to the 0.1. And that'll do it for this video for section 3.10. And we worked problems 31, 33, and 35. Thank you.